So this is a tangent line question. Let's have a look. They've given us the function. Now take note, the reason they say x can't equal minus 2 here is because if x is minus 2, then under the line this would equal 0, and you cannot divide anything by 0. Maths does not like it. It means it's an undefined value, which is not good. So it just can't be done. The question is to find the coordinates of the points at which the slope of the tangent to the curve y equals fx is minus, 1 over 4. That is a very long-winded way of saying find the coordinates where the derivative is a quarter. The slope of the tangent curve is the exact same thing as the derivative. Okay? So it's the slope of, if you had a line here that just touches it at this point, it's what that slope would be. So it's the slope of that point. So let's see. So this is our function, get the derivative. Now you can see that this is one row of the differentiation table, if you like, divided by another. So you need to use the quotient rule. Okay, quotient rule looks like this. If it's u over v, in this case 2x is u, and let's get a text box here. So in this case u is equal to 2x and v is equal to x plus 2. It's a really good idea to write that down before you start plugging things into formulas. It makes it less likely you'll make a mistake. You can also then say that that du dx, or u prime of x is equal to 2, and that v prime of x is equal to 1. So the derivative of a constant is 0, the derivative of x is 1. Okay, so it's a good idea to write that down like they have it here. And then you plug in the quotient rule. I would write out the quotient rule before you start plugging values in, so write this out, and then you can plug, then it's just a case of matching up what you've written down here into the formula. So v, which is the number underneath, times the derivative of the number on top minus the number on top times the derivative of the number on the bottom. Makes it much easier to write this out and write out the formula. All divided by the number on the bottom squared. So multiply it out, simplify it, and set it equal to a quarter. Cross multiply here to deal with the fractions. Okay, so now we have a squared here. So what you can do is square root both sides. Square root both sides, but on the left here that could be plus 4 or negative 4, because plus 4 squared would be 16 or negative 4 squared would be 16, so it could be either. Which makes sense, it's quadratic, so we should get 2 values of x. So we split it down the middle here, and we deal with each one separately. X plus 2 is equal to 4, which would mean x equals 2, or x plus 2 equals minus 4, which would mean x equals minus 6. So now remember, to get the points, when we're getting our y value, you must plug it back into the original equation. You won't get the y value by plugging it into this. If you plug it back into this, you get the slope, which is a quarter. We already know that. You want to get the y value. So you plug it into the original equation here. So for each one, plug in 2 and minus 6 separately. So one point is 2 and 1. Another point is minus 6 and 3. This is your answer, 2 different points. So there's 2 points in this curve where the slope is a quarter.